All right, today we're putting on our clinical detective hats. Our mission? To solve a really fascinating biological puzzle that literally shows up on a person's skin.
You know what I'm talking about, right? You've probably seen it, maybe in a movie, or heck, maybe even in real life. That distinct yellow color that just doesn't look quite right. What on earth is the body trying to tell us?
Well, that yellowing is called jaundice. And here's the first thing you have to get straight. Jaundice itself isn't the disease. Think of it more like a giant, flashing warning light, a distress signal that something, somewhere in the body, has gone wrong.
So buckle up. Over the next 5 minutes, we are going to trace the journey of the little molecule that causes all that color. We'll figure out what happens when its trip gets messed up, and most importantly, we'll learn how to use lab tests to crack the code. This is absolutely essential stuff for getting a real handle on liver function.
So clinically speaking, jaundice is that yellowing you see, and it's all caused by a pigment called bilirubin building up in the body. We all have some bilirubin floating around, but you don't really see it until the level in the blood climbs past about 3.0 milligrams per deciliter. That's kind of the magic number.
To figure out what's going wrong, you first have to understand what right looks like. The best way to think about this is to imagine bilirubin processing as a factory assembly line. It's a really neat 5-step process.
Okay, so it all kicks off when old red blood cells get recycled. They break down and release something called heme. Heme gets converted into our raw material, unconjugated bilirubin. Now this stuff can't dissolve in water, so it needs a ride. It hops onto a protein called albumin, which is like its personal taxi to the liver. Once it's in the liver, a special enzyme swoops in and conjugates it, which is just a fancy way of saying it makes it water-soluble. From there, it gets dumped into our bile and shipped out to the intestines. And then, bacteria in our gut work their magic, turning it into urobilinogen, which is actually the stuff that gives stool its brown color. See? When it works, it's a perfect system.
Okay, hit pause. This slide right here, this is a super high-yield concept you absolutely have to know. The difference between these two types of bilirubin is everything. Unconjugated is not water-soluble, remember? It's stuck to albumin, so no matter how high its levels get, your kidneys can't filter it into your urine. But conjugated bilirubin, that's the opposite. It is water-soluble, so if it starts backing up in the blood, it absolutely can and will spill over into the urine, making it dark. Please, please remember that. It's a huge clue.
All right, so we've seen the perfect assembly line. Now let's look at what happens when things go haywire. The location of the breakdown is what tells us everything.
First up, you can have what's called a pre-hepatic problem. Think of this as a supply issue. The liver, our factory, is working perfectly fine, but it's just getting completely overwhelmed with too much raw material. This is what you see in something like hemolytic anemia, where red blood cells are getting destroyed way too fast, flooding the system with all that unconjugated bilirubin.
Next, you can have a hepatic problem. And you guessed it, this means the factory machinery itself is broken. Maybe there's damage from something like hepatitis, or it could be a genetic thing like Gilbert syndrome, where that key enzyme we talked about just isn't working at 100%. The problem is inside the liver.
And finally, there's a post-hepatic problem. This is a shipping issue. The factory did its job. It made the final product, that water-soluble conjugated bilirubin, but the exit is blocked. A gallstone or maybe even a tumor can physically block the bile duct, causing everything to back up.
And boom! This table is your cheat sheet. It puts the whole diagnostic puzzle right here on one slide. Look, with a prehepatic issue, you get high unconjugated bilirubin in the blood, but you see none in the urine, right? Because it's not water-soluble. But with a posthepatic blockage, you see high conjugated bilirubin, which does spill into the urine. And because that bile never makes it to the gut, you can't make any urobilinogen, so it's gone from the urine. Hepatic causes, well, they can be a mix of both since the damage can be all over the factory.
So let's talk about the tools we use to figure this out. These are called liver function tests, or LFTs. The best way to think about them is as the liver's report card. It tells us exactly what's going on.
First, we've got markers for when the liver cells themselves are damaged. When these cells, called hepatocytes, get hurt, they basically leak their guts into the bloodstream. We look for two key enzymes, ALT and AST. Now, ALT is the one that's way more specific to the liver. So if you see a high ALT, that's a pretty strong signal that liver cells are in trouble.
Now here is a classic clinical pearl. You will see this on exams. If you look at the ratio of AST to ALT, and the AST is more than double the ALT, you should immediately start thinking about alcohol-related liver disease. It's an incredibly useful pattern that helps you narrow things down fast.
Okay, so what about a blockage, a plumbing problem? For that, we look at different markers, specifically ALP and GGT. These guys hang out in the bile ducts, so when there's an obstruction, their levels just go through the roof. Now, ALP can also be high if there's a bone issue, so we use GGT to confirm. If GGT is also sky high, you can be pretty darn sure the problem is coming from the liver's plumbing.
Okay, we've got the blueprint, we know the ways the system can fail, and we have our diagnostic toolkit. So now, let's put it all together and crack a case.
Okay, check out this report card. Total bilirubin is high, sure, but look closer. It's almost all conjugated bilirubin. We see bilirubin in the urine, but urobilinogen is totally absent. And look at those blockage markers. ALP and GGT, they are way, way up. So, what story are these clues telling us?
The verdict? It's crystal clear. The factory is working just fine. It's making the conjugated bilirubin, but it can't ship the product out. It's backing up into the blood, it's spilling into the urine, and those blockage alarms, ALP and GGT, are screaming. Because no bile is reaching the gut, no urobilinogen is being made. This is a textbook picture of post-hepatic obstructive jaundice. The shipping route is blocked. Mystery solved.
And that's really the whole point here. It's not about memorizing a bunch of random lab values. It's about seeing the pattern. It's about understanding the story that the numbers are telling you. The pattern tells you exactly where in the assembly line things went wrong.
By learning to read these stories, you can decode the liver's distress signals and really nail down the problem. So, I'll leave you with this. The next time you see a liver panel, what clues are you going to look for? The type of bilirubin? The enzymes? What's in the urine? Now you know it all fits together.